Modulo arithmetic. Let us see this question. What is the remainder when we divide 15 by 7? So here we are dividing 15 with 7, and you can see that in this case we'll have to take the quotient as 2. So 7 into 2 is 14, and what we get the remainder as 1. When we are dividing 15 with 7, the remainder is 1. So applying Euclid's division lemma, we can write this as 15 equal to 7 into 2 plus 1, and so the remainder is 1. And we can rewrite the same using the modular concept. We can rewrite this as 15 modulo 7. That means, it simply means what will be the remainder when we divide 15 with 7, or in short form we write modulo as mod. So this is 15 mod 7, or 15 mod 7 will be, as I already discussed with you, that it means what is the remainder when we divide 15 by 7. So 15 mod 7 is 1. Now let us take another example. Say, let us find the value of 23 mod 6. So what is 23 mod 6? It simply means what will be the remainder when we will divide 23 with 6. So let us divide 23 with 6. So what we are getting here, 6 into 3, 18, and this 18 we subtract from 23, so the remainder is 5. And remember that the remainder has to be always less than the divisor, and at the least can be 0. So here we are having 5 as a remainder, and it is correct as why? Because it is less than the divisor. So applying division, Euclid's division lemma, we will be having 23 equal to 6 into 3 plus 5, and the remainder is 5. So we can write the value of 23 mod 6 as 23 mod 6 is equal to 5. Why? Because the remainder is 5. Now let us take another example. Find the value of minus 17 mod 4. So in this case what we are going to do, we will divide minus 17 with 4. So let's start dividing this one. 4 will divide minus 17, and will not here the quotient will take minus 5. Why minus 5, not minus 4? Because 4 into minus 4 will be minus 16, and minus 16 is bigger than minus 17, so it is not possible. Because when we multiply the divisor with the quotient, the value should be always less than the dividend. So 4 into minus 5 is minus 20, and minus 20 is smaller than minus 17, so it is not wrong. So we can write here minus 20, and changing the sign, so it will become plus. So minus 17 plus 20, that is 3. So the remainder is 3. So therefore we can say that since minus 17 is equal to 4 into minus 5 plus 3, therefore remainder equal to 3, and therefore we can say that minus 17 mod 4, that is equal to 3. Now let us take one more example. Say, let us find the value of, say, 27 mod 8. So what we'll get in this case, what is our requirement? Our requirement is that what should be the remainder when we divide 27 with 8. So let us do the division work. So 8 will be here, 27. Our 8 is the divisor and 27 is the dividend. So 8 into 3 is 24. So 24 we subtract from 27. So the answer is 3. So what is the remainder? Remainder is 3. So the value of this will be 3. But we will write in a systematic way, proper way. So solution here, 27 is equal to 8 into 3 plus 3. Therefore, remainder is equal to 3. Therefore, we can say that 27 mod 8 will be equal to how much? 3. Now let us take one more example. Find the value of say minus 17 and mod 2. So let us see what will be the value of this one. Same as earlier. So what we'll do, this 2 will divide minus 17. So 2 minus 17. Now we'll not take minus 8 as the quotient, because 2 into minus 8 will become minus 16. Minus 16 is bigger than minus 17. So what we'll do is, we'll take this as minus, here we have not to take minus 8, but we can take minus 9, because 2 into minus 9 is minus 18, and minus 18 is smaller than minus 17. So changing the sign, so what we are getting is minus 17 plus, this is 18. So minus 17 plus 18, that is 1. So what is the remainder? Remainder is 1. So we can say that the value of this is 1. So let us write in proper way. Solution, minus 17 is equal to 2 into minus 9 plus 1. So whenever the number is negative, put in bracket. And what is the remainder? A remainder equal to 1. Therefore, we can say that minus 17 mod 2, the value of this will be equal to 1. So this is how we have to solve questions based on the type A mod m. Now let us see some rules regarding this one. So modulo arithmetic, let m be greater than 0 and AB belongs to Z. Then if here also this CD belongs to Z, so this is a part of this only. Let m is greater than 0 and AB belongs to Z and CD belongs to Z. Then if A is congruent to B mod m and C is congruent to mod D mod m, then you can add the left side as well as the right side. So A plus C will be congruent to B plus D mod m. Also we can multiply them. A into C will be congruent to B D mod m, and A raised to m is congruent to B raised to m mod m. Similarly you can have here also C raised to m is congruent to D raised to m mod m. And also we can multiply with any constant both sides, provided that it should be a integer. So AK will be congruent to BK mod m, and same way CK is congruent to DK mod m.